In Unit 4, or in Unit 3, the test we just took, we were multiplying what? Binomials and trinomials. And what do we call it if they're many? Monomials. And if it's more than... Thank you, polynomials.
Yeah, there you go, Jared.
So we were multiplying polynomials. Unit 4 is called factoring polynomials. Now factoring, multiplying, here, we have the definition. Factoring undoes the multiplication. So you guys remember back in elementary school when you would get a number and you did the factor tree for it to get all of the factors? Factor means a piece of the product. Okay? So when we factor polynomials, this time we're not putting it all together, we're breaking it apart. Okay, so we're undoing the multiplication. Undoing multiplication is the same as what? Good, division.
I forgot how to do that since it was so long ago.
Remember how when we were multiplying polynomials, how did we, come on.
We factor it by doing...
How would we multiply these two binomials? We had two methods. What were they? Box or FOIL, right? And because I didn't give myself a ton of room, we could FOIL these things. We multiply x times x, which gives me x squared. X times 3. You can still use the box method. 2 times x and 2 times 3, right? And all of that would come out to x squared plus 5x plus 6, right?
Yes.
Okay, this has how many terms? Your answer. 1, 2, 3. So what's it called?
Polynomial.
Good, trinomial. Okay, so if there are 3, we call it a trinomial. Now we're going to be working with trinomials a lot in this unit.
So why does it say factor of polynomial?
Because a trinomial is a polynomial.
It is?
So is a binomial. Poly means more than 1. But our binomials and trinomials just have special names. Okay, so, well, x times 3 gives me 3x, right?
Yeah.
And 2 times x gives me 2x. 3 plus 2 is 5. I just didn't show all of the steps. I just went from this is what we used to do and we would get this answer, right? Yeah, you can still do the box method. Now, in factoring, your problem is going to be the trinomial. So they're going to give you the trinomial, and you have to be able to break it up into 2 binomials. So we're just doing it backwards.
That's easy.
Okay? Okay, today there's different methods for factoring. This is just one of them. Today we're using the GCF method, and the reason we use GCF first is because we're always looking for GCF first. Who remembers what GCF stands for? Good. Greatest common factor. So please write down that definition so you don't forget.
I figured it out because Brooke said it like 10 minutes ago.
The greatest common factor, or we call it GCF, is the biggest number that goes into all of the terms. So the only thing we're doing today is we are finding the GCF of polynomials, and we are doing what we call factoring it out. So we have some steps on how to find the GCF. Okay, step 1, we want to write the prime factorization of each term using a factor tree. So we're going to do a factor tree for everything. And we are going to circle the common factors.
So we are doing factor tree.
We are going to do a factor tree.
Why didn't you tell us?
Okay, step 3, we're going to multiply the common factors together, and that's going to give us our GCF. Okay, so now we know, guys, now we know how to find the GCF, but how do we factor using the GCF? So 3 more steps. What we have to do is we have to find the GCF of each expression. We need to factor out the GCF, which means we take it out, and we write what's left on the inside of the parentheses. We have enough time for one example. Example 1.
Oh, you're smart.
I know. Example 1. We have x squared, and is this a positive 4x or a negative 4x?
Positive.
It is a negative 4x.
Oh, 4x.
Okay, your instructions are going to be to factor using the GCF. So the first thing we have to do is find the GCF. So what are the factors of x squared? What things multiply to give me x squared? Good, x times x. So we're going to write that, x times x. We also have negative 4x. What are the factors of negative 4x? What things multiply to give me negative 4? Bobby.
Negative 2 and 2.
Okay, I'm going to do a factor tree over here. Negative 4.
X.
Oh, negative 4. Well, we're just doing the 4 right now.
So
Okay.
-2x.
What are two things? First, we have a negative 1, right?
Yeah.
Negative 1 times what gives me negative 4? Positive 4. Anytime you have a negative, start with negative 1. Okay? And then 4 factors into what? 2 and 2. So what are the factors of negative 4x? Negative 1 times 2 times 2 times
X.
x.
Why do you make it all difficult? 4x.
Okay? So all I did was write out every single prime factor.
Why do you have to put negative 1?
Because it's a negative number.
Is that it?
What if they both had a negative 1 in there?
Why can't you just put negative
No.
times 2 plus or...
We need to, you guys, we need to write all the factors out because later when we get to bigger numbers, it's going to help us.
That's our answer?
No, what's the GCF? What do they have in common?
X.
X. So you circle that and our GCF is X.
So don't we put GCF?
Okay, so here's our GCF. It's X. We're not done. Our instructions were not to find the GCF. They were to factor. Finding the GCF was step 1. Step 2, we want to factor out the GCF. So that means we're going to divide everything out. So we would have X.
Quit.
And if I divide X squared by X, what am I left with? X. Negative 4X divided by X? Negative 4. Okay, this is factored. All we did was we took the GCF and we pulled it out. How could I get it back to the way it was? Distribute. All we did was undo the distributed property.
Bam.
Okay?